Thanks, Federica. Thanks for the presentation and also for the invitation. So I will present two projects. So one is actually finished. It began on, it was January, I think, 2021, and finished last year on July. And the second one is the POLINE project is currently ongoing. It started on the 1st of January, and it will finish at the end of next year. So they, let's say that the second one, the POLINE project, is, should represent a kind of continuation of the first one. We are dealing with basically developing AI tools in the forms of prototypes. So they are not like applications that are ready to be used in the like in judicial activities, but they represent a kind of mocks and example of how AI can be used in the judiciary. We are targeting actually the use of AI in the judiciary. In particular, we have been focusing on the field of tax law. Actually, the first project, ADELE, was also dealing on with trademarks and patents law, so two fields of the law. And while the second one, the POLINE project, is dealing with tax law, specifically on VAT law. So we are targeting this very specific area of the law. So I will mainly present the first project because it is the project where we actually now I will present you what is the main output of the project. It is actually a platform that is easily accessible and you can navigate through it. It is a quite rich resource, and it gives a kind of grasp of what are the different possible applications of AI for judicial decision making as a support to judicial decision making. I will say something about POLINE. POLINE is an ongoing project, so I will just present what is the overall approach of the project. So let us start. So as I said, ADELE stands for Analytics for Decision of Legal Cases. So analytics is a field that merges AI, natural language processing, statistics in general, and apply to legal cases. So the objective was to provide a methodological framework for legal analytics for court decision and implement this framework into a pilot tool. We dealt with two legal systems, two judicial systems, Italian and Bulgarian. We have a marvelous. We also have now in the POLINE project, we have marvelous partners. The APIS Europe is a legal informatics company established in Bulgaria, which has supported us in actually building the final platform. And it dealt, the ADELE project dealt with two, as I said, two fields, the trademark and patent and the value-added tax domain. So there have been several other partners in this project, including the UI. Federico was the leading person of the UI team. So we will, in a moment, I will show you the platform. But this is an overview of, can we make it bigger? Because I think it's, so it's a representation of the different modules. So we call it like that. So modules, different functionalities that you can find in the platform. So you have a part where basically you have a legal database, so a collection of cases, which are organized according to certain criteria, in particular decisions that have been delivered by specific courts on specific matters. So there is one of the application of legal analytics, namely the automated extraction of keywords. So you can use like natural language processing AI techniques to extract keywords and organize the decision based on such keywords. Then you have on top right the legal ontology. Legal ontology, I don't know if you are familiar with this application. They are basically a way of representing knowledge, in particular legal knowledge, in a structured way. In particular, we have developed a legal ontology of VAT and concepts and trademark and patent concepts, and we have implemented it in a visualized formats, which helps judges to navigate through the case law by basically visualizing different concepts that are connected and read and consult the relevant cases. And then on the bottom part, you can see two of let's say the core of the platform, and the two functionalities that wanted to show how AI actually can be used in this domain. In particular, we engaged in what is called argument mining. So basically extracting legal arguments from cases and the field of outcome prediction. So basically what is generally I mean, when we refer to predictive justice, generally we tend to look at this specific task. So the idea of predicting the outcome of a case. Although, I mean, predictive justice can actually be referred to a broader set of application. So whenever there is a kind of prediction of unknown knowledge. So also, for example, argument mining. So whenever you may use automated tools to classify arguments, which is basically the purpose of argument mining. You engage in a certain way in a kind of prediction. Anyway, so this is let me just click on the link. So this is a way. This is the pilot tool. So as you can see, it's a platform. You can, if you want, you can surf on the website. This is basically it's the URL. There are different sections in the platform. So I will show you, for example, the section, the Italian section on value-added tax. So you have all the different, I mean, all the cases that have been collected and are part of the database. We have 235 decisions. You cannot see it because I have to, wait. Okay, so this is the database. So you have all the different decisions. You can see here, these are the keywords that have been automatically extracted. And we also engaged in the automated extraction of summaries. This is something that, I mean, this project was designed in a let's say 2 years ago, 2.5 years ago, and it was before like the breaking out of large language models. So these are different types of approach in extracting in summaries. What we do now is generally to use large language models to automatically summarize cases. Anyway, we have other, so you can see here there are different filters you can use to, this is in Italian because we dealt with Italian cases. but this is basically are the different commissions that in Italy would deliver tax decisions. Then here in the top of the screen, you can see the 4 modules that I presented. So you have the modules on outcome prediction, citation analysis. It's part of the legal analysis module. It's basically a way to, so we ask basically the system to automatically extract citation within the decision. It's a very useful functionality because it allows you to navigate through the different cases which refer each other. Then we have the argument extraction. So as I said, the possibility to upload a decision and having all the arguments, legal arguments made in it being extracted automatically, and the ontology. I will just show you like the ontology just to represent how. So basically, this is a legal ontology of VAT concept. What you can do is it's quite huge. You can see there are different concepts that are related to, let me see whether I can manage to, it's a bit complex. Service, so service is one of the key concepts in the VAT, and you can have different type of service, and basically this allows you to, for example, you can have different information, what is a service, a definition, what are the relevant sources in the Bulgarian, Italian, and EU law, and some notes given by the expert. So it was an ontology made by, it is an ontology made by experts. You can also have a tree visualization. You can see here these are other different concepts that are relevant to VAT case law, for example, the transaction, the person, legal event, and different concepts that you can click on and have the different you can here search for related case law, and all the case law that appear here are in a way connected to the concept. They elaborate the concept. Okay. So this is the first part of the presentation. Now I wanted to show you what is the methodology behind this platform. So, okay. So basically, we are applying machine learning to legal text. This is the general methodology of the project, especially for the AI-powered module. So what does it mean? So we have a first step called annotation. So we have legal expert that provide, their expertise by directly annotating legal text. What does it mean? So we have the text of the decisions, and we include within this text, using markup languages, we include knowledge that is, pertains to expert knowledge, basically, and we include such annotation on the text. Annotation may pertain to different legal information, such as, for example, if you are annotating a legal case, a legal decision, judicial decision, you can annotate different part of the sentence of the decision. For example, so the claim of the parties, argument of the parties, the facts of the case, and of course also the outcomes. This is the annotation phase. Then there is the model training. No? We know that machine learning basically pertains to the field of refers to trained AI models, so systems that are learns how to accomplish certain tasks by learning that task from data that are provided by experts. So what does the system do in the model training phase? So it creates a mathematical representation of the text, what is called in technical terms an embedding, and then learns a statistical model which correlates natural text with annotations. So basically, it learns to reproduce what human expert did. So basically, how to interpret a text and link such natural text representation to expert knowledge. At this point, the system may also be able to correlate different parts of the annotated text. So, for example, the system may be able to correlate the parties with certain arguments. So it may be able to identify a relevant statistical correlation between, let's say, certain parties, the name of the parties, and their arguments, or maybe certain requests and claims, or possibly also, and we go in the field of outcome prediction, the facts of the case and its outcome. So basically, the system comes up, learns a statistical model correlating these different parts of the case. So I want to provide an example, a concrete example of how we engaged in what I called argument extraction, argument mining. So we want basically, so the final objective is to provide the users, so judges, with a quick analysis of the argumentative content of a judgment. So what are our desiderata? We want the system to automatically identify argumentative parts in the judgment. What does it mean? So, for example, if we look at arguments as a set of premises and a conclusion, we wanted the system to automatically identify premises, what is a premise, and what is a conclusion of an argument. We may want also the system to classify whether a premise is a factual premise or a legal premise, so it deals with legal aspects. We may also want the system to classify different argumentative types. So we know that there are some stereotypical way of arguing, no? So, for example, using arguments from precedents or literal interpretation, teleological interpretation. So this is something that, for example, argument theory has provided in terms of like structured knowledge. And another aspect is to identify the links between premises and conclusions. So if we want to reconstruct an argument, then we need to identify what are the relationships between the premises and the conclusion. So it's a kind of complex activity if you want to formalize it, no? So to do that, we create annotation guidelines, no? So to accomplish the first phase. Annotation guidelines, so are supposed to lead basically annotators to apply their knowledge to the legal text. So for example, you see there is the distinction between premises and conclusion, different tags that are to be inserted in the text, and then a different characterization. For example, you have if you have a premise, you can have a legal or a factual premise, which is defined by the use of specific symbols. For example, if you have argument from rules, then you will mark with those specific tags that you see on the right of the table, that specific argument. This classification is not arbitrary, it's based on a important theory in argumentation theory provided by Doug Walton, is one of the leading scholars in the argumentation. The same for the different types of links that can be traced by premises and conclusion. For example, I mean the typical logic relations in an argument is the support. No? So you have a premise supporting a conclusion, for example. But you can also have attacks. So you have premises attacking other premises and leading to and supporting a conclusion. So different types in which the atomic parts of an argument can relate to each other. This is a representation of an annotation. This is a part of a decision where an expert has included the different tags. So it performed the annotation. You can see here there are different parts, a conclusion and different premises which are linked one to another. We train the model and then we ask the model to apply its statistical model to different, to new data, so data that have not been used for the training. These are the technical results. So basically you have what you need to look at is the macro measures, namely which represent the accuracy. So how precise is the system in classifying the correct, identifying the correct answer that is the answer that a human expert would provide to such an instance. So of course it is a range from 0 to 1. So in certain cases, for example, when the system has to classify, for example, whether a premise is a legal or a factual premises, the result, for example, in the case of trademark, what is TP? It's trademark and patents for the Bulgarian dataset is 0.87, which is a quite good performance. It is a probabilistic approach to legal determination, so it is not a deterministic way of treating legal knowledge. So there is always a margin of mistake. What we did, in addition, is to have experts evaluating this tool and the different modules. I just presented the way we developed the argument mining modules. So we had different events during the project where we involved judges from the Italian legal system and the Bulgarian legal system, which provided feedback for the platform. Several limitations, maybe, there have been many in terms of, for example, we had some problems with data collection. It is important to have good data that you can process and that you can use for training the model. Especially, we used only a limited number of decisions, so not all decisions that are part of the legal system. So it is a kind of partial view that the system has when making its prediction and classification. Data annotation is a quite intensive work, as you may imagine. So you have experts reviewing all the cases that are part of the training set, and you have them labeling all those cases, which is a quite demanding activity. There is a problem of explanation, no? I think that you have been introduced this morning, but maybe also in previous sessions, about the problem of explanation, which is a core, a key issue when dealing with the use of AI in the judicial domain. Our system is limitedly explainable, so it does not actually provide a consistent and coherent legal explanation as to why for example, the system has classified an argument in certain way. So this is of course, let's say, by design limitation of our approach. But still, it it has shown how this system can actually be used and developed for certain activities that may support judicial decision making. I just wanted to finish by introducing the second project, so the POLINE project. It's a bit different, still has a focus on the VAT domain. But what I want to underline is that like the uptake of the new, what we could call a new paradigm in the AI, so the generative AI paradigm, no? So what also Giuseppe has introduced this morning on like using large language models, generative AI models to carry out different activities. POLINE indeed represent a step forward in the use of AI for the judiciary, in that we used large language models to extract what we call the principles of law in judicial cases. What principles of law are, I mean, it's a kind of construct that is frequently used in, at least in the Italian language, to refer to kind of authoritative interpretation of the law. For example, when dealing with the European Court of Justice, we say that whenever there is it's a contested concept, so it is not something that is shared by all scholars, but still it's a way to refer to those leading interpretation that are most probably to be cited, to be recalled when, for example, the Court of Justice decide on a specific cases. It generally refer to its previous case law, referring to specific principle of law. So this is the aim of the project, which is coordinated by the University of Bologna, also involves the UI and Madalina in this case. And so here, as I said, we use large language models. What are large language models? They are AI systems that are capable of understanding and generating human language by processing vast amount of text data. So you know probably examples of large language models in ChatGPT. ChatGPT is powered by the GPT OpenAI model. GPT stands for Generative Pre-trained Transformer. So, and I mean, it explains very well what this application can do. So it is generative, so it creates text. It is pre-trained, meaning that the application was trained on large amounts of data, especially textual data. So we do not need to like train every time we need to use the model. We don't need to train it from scratch. We can use a pre-trained version of it. And then transformer, because these applications are based on this particular technology that builds on neural networks. So they are kind of powered version of deep neural network. Large language models are now being used in various domains like legal research, summarization, document drafting, and Q&A. I'm about to finish. So this is our representation of a judicial principle of law. Now, this is an example extracted from one of the decisions of the European Court of Justice in the VAT field. So this is our definition of a judicial principle of law, a portion of text that is extracted from the argumentative part of a judgment, which contains an interpretation of a rule, the consequences stemming from the interpretation of a rule, the subsumption of a fact within a rule, and the qualification of a factual hypothesis, a concept contained within a rule. What do we do now? So we do what is called prompt engineering. So we try to develop a prompt, so a request written in natural language to the large language model, so as to prompt it, the model, to basically give what is the requested response. In particular, we ask the model to, according to our definition, to identify within a specific decision what are the principles of law that a human expert would identify in such a decision. So you can see here, maybe it's a bit blurred, but on the left you see the definition in the prompt of what a judicial principle of law is. And there are different techniques that you can use in prompt engineering. For example, you can say what is a judicial principle of law, what is not a judicial principle of law, so to let the system like build its own understanding of what indeed JPOL is. And then we have some results. We still need to actually present them in a structured way in a paper. I think, I mean, we are writing it and we will present it to an important conference in AI and law. But we have promising results because how do we test the model? Basically, we compare what the model does with what experts do. Basically, we have some expert, we had some expert annotating a very small subset of cases of judicial principle of law, and then we compare what is the performance of the large language models with what legal experts have done. And the results are pretty satisfactory. So we see that if these large language models are presented with a quite detailed representation of what is the legal knowledge that we want to extract, then they perform very well. So I finish with the presentation. I thank you for the attention, and I would welcome any question. And